So one problem that most developers encounter when they start working with threads are concurrency issues. And there's a whole range of concurrency issues that can crop up in multi-threaded applications. This is really why multi-threaded application programming is difficult. The first concurrency issue that we're going to talk about here is one called synchronization. And this is basically the problem of sharing some memory in Java. When you create different threads in Java, those threads can access the same object, and how they access that object can cause some kind of synchronization problems. We're going to look at an example where we're going to see how two different threads accessing the same object can end up putting the object in an invalid state. And really what this boils down to is the idea that these threads don't have a separate copy of the data. And because they don't have a separate copy of the data, when the first thread is manipulating that data and the second thread manipulates that data, those things are going to cause some problems if they overlap or if they interleave. A good example of this is if you've ever made a to-do list and you've shared it with someone and you haven't quite updated that to-do list. Maybe you've picked up a task on the to-do list and you started doing it, and then whoever you've shared the to-do list with is actually doing the same task at the same time. There's a synchronization issue there because you're both working on the same thing, but you haven't synchronized. If you haven't come up with a formal way of saying, okay, I'm grabbing this task, so you should grab the next one down, then you might both end up doing the same thing. So let's look at an example of this in Java, just kind of an idea of how this could happen. I've got a real simple diagram here, and I'm showing thread A and a thread B, and they're both accessing this object in the middle here that has some kind of count. And I've got the count initially set to 1 here. Now, what can happen here is, let's say that thread A goes and accesses this object, and it's going to increment the count. So it's going to increase the count to +1, whatever it was, +1. And let's say thread B is going to do the opposite. It's going to look at this object and it's going to decrement the count. So whatever it was, it's going to -1. Seems like this couldn't create a problem. So whatever scenario you can think of, thread A comes in, increases the count to 2, thread B comes in, decreases the count to 1. That's correct. But here's the issue. In Java, an increment operation is not atomic. What I mean by that is it is not the only step. There's potential for thread B to come in and do something in the middle of thread A's increment. And this has to do a lot with the way that a Java statement can be broken down into some bytecode that might be multiple statements. So for example, when we talk about increment really is not a single operation. What it really is get the value, add 1 to what the value was, store the value. So this is actually 3 operations. Get the value, increase the value, store the new value. And when you think about it that way, if thread A comes in and it's going to increment the count on our object, so our count is 1, thread A comes in and it says get the value. Then at the same time, right after that, thread B comes in and is going to decrement the object. It's going to decrease the count by 1. It says get the value. They're both going to be holding 1 for the value. Thread A increments the value, so it does 1 plus 1 is 2. And then let's say it even stores it. So thread A will store a 2 in there. Thread B will then come in and decrement the value. So it had a 1. It decreases it by 1. It's 0, and it'll store 0. So now what's happened is you have an increment and a decrement, but you get 0 stored. So instead of it being 1, you've actually gone down 1 to 0. And this is something that you really don't want in your code. So you need some way to synchronize this so that when thread A is accessing this count, that it prevents thread B, says, wait a minute, let me finish what I'm doing. Let me treat my action as atomic, and then you can come in and do something and manipulate this object. Because if they're interleaving, if they're happening together, you can't predict what the result is going to be. It's going to depend on timing, and that's not something that you want in your multi-threaded application. And these are really the most difficult bugs to solve. If you haven't thought about this ahead of time, when this happens, if you can imagine, it's going to happen very rarely. But when it does, it's going to create a big mess that is going to be very difficult to detect and understand why it happened. So the other big concurrency issue I think that a lot of people face is deadlocks and starvation. And there's more than this, but we're just going to cover this because these are the two big issues I think in Java programming that beginning Java developers encounter. And this idea of deadlocks or starvation is basically this idea that you have threads that are competing for resources. And because some threads might need multiple resources, those threads could get into a situation where neither of them can do anything because both of them are waiting to get that resource. And this isn't going to make a lot of sense yet until we actually solve the concurrency issue. But if you think about it, when we solve this concurrency issue that we had seen before, the synchronization issue, we're going to have to make it so that, like we said before, we said thread A needs to be able to tell thread B, hold on, wait until I'm finished, and then you can do your thing. Well, this kind of leads us down this path where we get into a deadlock situation, where if we've now told thread B to wait until we're done, well, what if thread B is using something that thread A needs in order to be done? Then thread A will never finish, and thread B, which is holding something that thread A needs, will never finish, and they're both going to be stuck and you're going to have a deadlock. A similar issue can happen called starvation, where basically thread A keeps on being able to run, but thread B can never run. It may be thread B is set so that it's trying to grab a resource, but if it can't, then it's going to just pass the execution to thread A, and thread A keeps on going, and thread B never really gets a chance to operate. It goes so slowly that it's basically being starved. And in this module, we're not really going to address how to solve these deadlock and starvation problems because these are very difficult problems, but I want to introduce them to you in this module because you need to know that they exist. And you just need to be thinking about when I try to solve other concurrency issues, when I try to solve synchronization issues, when I try to make it so that a resource needs to be locked in some way, or that two threads that are competing for a resource have to take their turns, you have to make sure that you don't then turn that problem into a new problem called a deadlock, or that you create a starvation problem. So very simply, the basic concept of a deadlock is just when two threads are competing for the same resource and one thread needs to give up a resource in order for the other thread to get it, and vice versa. Whenever that happens, both threads have to stop, and you end up with a deadlock. Your program. The last thing that we're going to look at here is how to fix the synchronization problem that we had talked about. So if you remember, with synchronization problems, what could happen is that we might have two or more threads trying to manipulate an object at the same time, and because of that, they could end up corrupting the data because they might be stomping on each other or interfering with each other and not leaving the data in a valid state. And that's because all these operations aren't atomic. What we had talked about was if you had a number that was being stored in a variable and you try to increment it in one thread and decrement it in the other thread, it might actually end up doing the wrong thing because in between those states, it could have one thread could have gotten it while the other thread was in that method trying to increment it. So one way that we can prevent this in Java is we can use a synchronization, or we can declare our method to be synchronized. And there's a few other ways that we can do this, but I want to show you the most basic example just so that you can understand how to alleviate these problems kind of at a high level. And if you need to get more detailed versions of this, there definitely are some more out there. But this will get you some basic understanding and some basic ability to be able to accomplish this. So let's look at our printer class here. In this example, we had set up, we are basically running this continuous printer thread. And in this continuous printer, we're calling this print using cartridge method on our printer. Now if I go into our print using cartridge, we can see that multiple threads would be entering this at one time. And in this example, it's not a problem because we're not doing anything with the internal state of the printer. So we're not going to really see an issue here. But just to demonstrate this concept, let's see how these threads are interacting with this method right now. So I'm going to print every time that we enter this, I'm going to print entered, and then I'm going to print out the actual ID of the thread. So we're going to do this thread dot current thread, and then we're going to say get ID, and that just gives you the ID of a thread. All threads have their own unique ID. I'm going to do the same thing when we exit this method. So we're going to call this print line, and we're going to print exited right here. So what's going to happen is every time a thread comes into this method and calls it, we're going to get entered, we're going to get the message, and we're going to get exited. So if we look at what's going on here, I've got a thread pool set up. I set it up to 100, so all these threads are going to be running at one time. And let's run this and see what the results look like. So you can see here, I'm going to scroll all the way up to the top. We've got thread 8 entering, and then we have thread 11 entering. We have thread 10 entering, we have thread 9 entering, we have thread 13 entering, and then 10 has finally exited. It actually exited before 8, and then 10 entered, and then 11 exited. So we have all these threads entering and exiting at different times. A lot of threads are entering before the other ones exit. And anytime that happens, it's a potential for a problem here because it could be manipulating data, and we might be expecting that everything in that method is operating as an atomic operation or as one. We don't want it to be interrupted, especially if it's operating on some internal data for the printer. Let's say it was changing a page count or doing something with the printer and it was setting its state. By having all these threads entering here, they could be entering at different points where that data is not in a consistent shape, or it might be corrupted by having all these threads enter. So we can solve this problem really easily in Java. All we have to do is go into our printer class, and we're going to change this so this method is going to use synchronized. So now we just declare this as synchronized, and this keyword in Java will make sure that only one thread can enter at a time. So all the other threads are going to block here waiting while one thread enters and goes through this. Now if we run this, you can see how this is actually working. So I'm going to scroll up to the top here, and you can see here we're getting thread 8 enters, thread 8 exits, thread 10 enters, thread 10 exits, thread 9 enters, thread 9 exits. Threads are not interleaving here between this method, so multiple threads can't actually get into this method until the previous thread has gotten out. So that's the basic example here of using synchronize, and this is very useful whenever you have a method that you know is going to be accessed by multiple threads and it's manipulating some data. You need to use a synchronize call or somehow synchronize it so that multiple threads aren't interacting with that data or calling that method the same. So let's go over what we covered in this module. Well, the first thing that we did is we talked about what threads are in general and the general idea of when you would use a thread, how it can be used. We gave some examples of a web server which really needs threads to operate and how you could use threads to create a responsive UI. Then we actually went through some examples of creating threads. I showed you 2 different ways that you could create threads in Java and just a simple thread that would do something very simple without worrying about some of the complexities and problems that could happen when you're running a multi-threaded application. Then we saw another method of executing threads using an executor, and we saw how we could use an executor to pass some functionality that we wanted to be threaded, and the executor would handle creating threads or using existing threads and run that for us. Then we talked about a very important issue in Java in threading, which is concurrency. We talked about some of the problems that could occur. We talked specifically about synchronization issues where multiple threads could be operating on the same object and could cause problems, either stomping over each other's changes or because they're interleaved, incrementing something and decrementing something at the same time and ending up with the wrong result where you have timing issues. Then we talked about another problem that occurs when you've solved these timing issues, which is deadlocking or thread starvation. And we talked a little bit just about this general idea. We didn't really go into how to solve this, but I just wanted you to have an idea of this potential problem that can occur when you're trying to solve concurrency issues. It's a little bit more of an advanced topic of how to prevent deadlocks, but you should be aware of this just so you know what is going on if your threads suddenly stop. Then finally, we went through an example, and I showed you how to solve one of the concurrency issues here. Probably the biggest one that you'll face is synchronization. So I showed you how you could use some built-in features in Java in order to do thread synchronization and to make sure that 2 threads competing for the same resource take their turns and don't try to overlap operating on that object at the same time. So that's it for threading. And in Java, threading is really quite a complex topic. We have kind of just broken the ice on threading, and really there's a lot more to this, and writing a multi-thread application is fairly complicated. But The good news is, for a lot of simple cases where you just want to be able to benefit from an increased performance and you have a very specific use case of using a thread, it's pretty much as simple as we covered in this module. But if you're really thinking about writing a multi-thread application that's going to heavily use threads, you're going to want to get some more in-depth knowledge and really study the topic of threads. Whole books have been written on the subject of threading and concurrency. Well, thank you for joining me on this course on Java development. I hope that you have learned a lot, and feel free to email me with any questions if something that I've said in this module or in this course needs further clarification or you didn't quite understand.